Welcome to the Z-Hut's Mad Scientist Laboratory. I'm Professor Z, and today we're going to attempt to take over the world using Arduinos. Grab your favorite Arduino board and put on your tinfoil hat, because it's time to build. Today, we will be attempting to take over the world by building a gas leak detector gun. And also, if you're not using this for detecting gas leaks, you can also use it as a prop ray gun for a Halloween costume. The main component of this is one of these MQ-6 gas sensors, and these detect methane, propane, natural gas, pretty much any flammable gas that you would be using around your home. And I just simply have it set up with the sensor here on the end of the tube, and I have a power button, battery pack, and then I just have an old analog meter here that detects the strength of the gas. So the closer you get to the gas source, the higher the reading of the meter will be. And then there's also a potentiometer here, and this is to tune the detection strength of the meter, so that as you get closer to the leak, you can increase the sensitivity, so you can narrow this in right to where the leak is. Now let me grab here. I'm going to demonstrate it working. Turn it on. As you can see, I also put an LED backlight on the meter. Now, I had already calibrated it, but it does take a few moments to warm up before it will start detecting. It's not quite warmed up yet. As you can see, when I do put butane gas underneath, the meter does go up and down. And it generally, I think it takes about a minute for it to warm up. And then it's at its most accurate. As you can see, you got to get once you get about an inch away from it, it'll peg the meter. But that's where this comes in. You can have the sensitivity decreased, and then once you get close to it, you can use this to increase the sensitivity so the meter doesn't move as quickly. And then you can zero in on the gas leak. All right, let's take a look at the construction of it. And then what we'll do is we'll go over and take a look at the sketch for it. So, well, first, it pretty much does look like something from one of the old black and white Flash Gordon sci-fi shows, a ray gun. And what it is just PVC pipe. This is, I think this was 1-inch pipe. We have a angled, it's not a 90, I think that's a 45 degree. I think that's what that would be. And then for the front, I have a reducer on here down, I do believe this is 1/2-inch pipe. Let me grab my ruler, I can check real quick. Actually, no, I think that's 3/4 inch. But the pipe I used is when you cut the slit in the middle in half, it fits across lengthwise perfectly. Now you can also get these not on these boards, and it just happened, this is the particular ones I had, they were on the boards. But I'm using the analog reading out of it, not the digital, so you don't really need this board. But if you got one of these, you could desolder it, or just get the MQ-6 sensor without being on the board, and you could glue that right to the front of this, and it would look a lot nicer, a little bit neater. But this is what I had on hand, this is what I used. I did order one of these. It's not on one of these boards, but it'll be a good month before that comes in the mail. So all right, then there's the body itself. This is called a conduit body. You'll find this in the electrical section of your hardware store or home improvement store. And they come in many different sizes. Just go with one that's just big enough to put all your stuff in. This again is one that I had on hand. I could have probably went with something just slightly smaller, but I had it on hand, and these aren't that expensive. I think this was like $3.99. So very inexpensive project enclosure, and it works perfect for this. Works absolutely perfect. So I'm going to go ahead and remove the handle, make it a little easier to see things here. So on the bottom, I have a little AA battery holder. It holds 2 batteries. Then it has the prongs that come out. I just drilled 2 holes, so these run through to the inside. Then I used super glue and super glued the holder on. It should stay permanently. Super glue holds pretty good. And yes, I am powering this with only 3 volts, but it is a 5 volt Pro Mini we're using on the inside. But we'll get to that in a moment here when I open it up. Then on the top, once again, we have a potentiometer. You're going to want a 10K. For this, it does matter if when you're doing analog reads off a potentiometer to your Arduino board, the value really doesn't matter, but we're not using this as an analog read to the board. We have it tied to the meter, from the output to the meter, so we're controlling that, and I found 10K works the best. I'm pretty much going to say you're going to want to stick with the 10K, otherwise you're not going to have much sensitivity control. It'll be too much or too little. You can try, but then I have simply an on and off power switch. And then I have an old analog meter. You can order these online. This one, I don't know, this came out of an old junk CB radio, stereo, something. When I find junk electronics at garage sales, I always take them because there's lots of parts like this you can rob out of them. All right, with that, let's open it up and we'll take a look at the inside. That's the wiring on the inside. Now, down here in the corner, because we're using 3 volts and we need to power the Arduino at 5 volts, we're using a voltage power step-up converter. And this is the exact one that's in there. It's right here. It's adjustable. This is a MT3608. You can get these on eBay. I think they're like just a little over $1 that's shipped, and it is adjustable. This little multi-turn potentiometer here, you put your voltage in, then you got your voltage out. You put your input, what you're going to be running, and you use this to set the voltage at 5 volts. And until those batteries go below the minimum voltage this needs to work, which I do believe is 1.5 volts, it will constantly keep it at 5 volts. As the batteries decrease, this won't go down at 5 volts. It will keep it regulated at 5 volts until the power supply voltage drops below what this needs to operate, and then it'll just shut off. Beans, you're not going to be using this a whole lot, most likely having it on all the time. This was the way to go instead of putting multiple batteries in there and then have to use a step-down converter. So then down here, we have one of these little mini breadboards. I was going to solder it together, but I have a whole bunch of these, and it was the perfect size to fit right in there. It has this peel back stick thing on the back. I just went ahead and used this. That way, if I want to modify anything in the future, in which I am going to be replacing this, like I said, I can just simply unplug something and plug something new in. And as you can see there, we've got our Pro Mini. That's the one I've got in there. All right, for the exact circuit on how to assemble this, just look in the description below. You'll find a link to this project's webpage. There will be a schematic on there, as long as the code that we're going to look at here in just a moment. The only other things to mention, I added a little LED here as a backlight. It's just hooked up to the power. Whenever the power's on, the LED comes on. And then I put a 330 ohm resistor in line in the jumper here. It's underneath the shrink wrap. There is a resistor in there. Then I have tons of these jumper wires, so to keep everything color coded so I could differentiate between stuff, I just went ahead and used some of my jumper wires because I go through these like crazy. When the old ones, the ends start wearing out from heavy use, this is how I recycle them. They just get permanently soldered into a project. All right, I think we've covered everything. Well, then of course there's the on-off switch here, whatever kind of switch you want to put in there. And to cut everything out, I simply used a Dremel tool with a cutoff blade to cut the notch out for the plastic. And then I used a cordless drill to drill the holes for the power switch, the potentiometer, and the 2 little holes for the battery pack underneath. I used a real tiny drill bit on the Dremel as well to drill that. All right, I think we went over everything. Once again, in the description below, you'll find a link to the web page. You'll find a schematic on there. Plus, I'll have a parts list. Oh, excuse me there. Plus, there will be a parts list as well. So, all right, I'm going to go ahead and fire up the computer. I'll catch you over there in just a second, and we'll take a look at the sketch that we're using to control this. All right, I've got the Arduino IDE opened up here. So what we're doing here first is we're just defining MET, just short for meter. That's our analog meter. That is on digital pin 3. In the void setup, we're just setting the pin mode for that as an output. We have a serial begin and a serial print down here. This is for testing when you're first setting this up, because you might need to change just a tiny bit down here. We'll get to that in a moment. In the void loop, we're just doing an analog read of, I've got the gas sensor on analog pin 1, so we're just doing an integer. We're calling it val for value. Reading that. Then what we're doing is we're constraining that value. We're going to keep that value between 200 is the minimum value and 1000 is the max. I found that just sitting in the room, no gas near it, it would get a reading between 50. As it warmed up, it got more towards 100. I found it works great running it at 200. And when I was putting butane and gas right directly onto it, it was pretty much hitting 1,000, maybe 1,001, 1,002. So I just constrained everything here. You should be okay leaving this alone. Then what I did next is, because we're going to be doing an analog write, we're taking that value and we're mapping it to a value of 0 to 255, because that's our analog write value, has to be between 0 and 255. So we're just mapping that. Now, you can play around with this a little bit. If your meter is smaller and you're way over pegging it, no matter how you're setting your potentiometer, you can drop this value down a little bit, maybe put it at 200, try it there. The constraint up here, most likely you're going to want to leave this alone, but if you do get into some problems where it just doesn't seem to be reading right, you're going to have to play around and experiment a little bit. Most likely you're going to be able to download this sketch, upload it to your Arduino, excuse me, wire everything together, and there is a good chance it's going to work. All right, so with that, just remember, go ahead, feel free to experiment a little bit. Then we're just analog writing our value that we just mapped. We constrained and mapped it, and then we're writing that value to our meter, and then we just simply got a 5 millisecond delay, just to help things run smooth. I like to put a minimum of between a 1 and 5 in any sketch. It just helps things run smoother. It's not just non-stop continuous with no stopping at all. So, all right, well, that's all there is to it. Remember, once again, look in the description below. You'll find a link to the project's webpage. You can find the schematic, parts list, the sketch, everything on there. So, all right, well, thanks for joining us here today. Please give us a thumbs up if you found this information useful. And remember, very, very most importantly, remember to always wear your tinfoil hat when you are building and programming your Arduino board. We don't want the government, the men in black, or the aliens to know what we're up to.